Hi guys, we're solving this math paper today. This is 9709, paper 1-2, pure math 1, February March 2023. The time is 1 hour 15 minutes. I'm going to be solving a lot of math papers throughout the year this time. Please do consider subscribing to the channel and liking the video. It helps with the algorithm a lot. Also, if you guys want, you could support the channel by subscribing to or joining my Patreon. It's The link is in the description. It's patreon.com/CAI paper solved. There are several tiers where you can get access to notes for different topics, as well as the OneNote file for all the solved question papers that I have for math, physics, chem, bio, as well as access to video meetings with me where we can discuss your problems in the $15 tier. So please consider joining the Patreon. So let's take a look at the threshold before we begin. So for paper 1-2, A was at 60. Right. The full mark is 75. A was at 60, B was at 52, C was at 42, D was at 33, and E was at 24. So they're like 10 marks apart, 8 to 10 marks apart. So A star should be at around 67 or 68, according to this threshold, right? It's hidden in the threshold, but it does exist. Let's begin. So I actually have the paper solved, just like my mechanics video. So we're just gonna go through the answers. Line has equation y is equal to 3x minus 2k, and the curve has equation y is equal to x squared minus kx plus 2, where k is a constant. Show that the line and curve meet for all values of x. So here you have to equate the two, the line and the curve. This is what I did in this step over here. Afterwards, just simplify it. Bring the x's on one side, so we end up with everything on one side rather. X squared minus kx minus 3x plus 2 plus k. 2k is equal to 0. So x squared plus k, and inside the bracket we have minus k minus 3 plus 2k plus 2 is equal to 0. Now, we need to show that they meet for all values of k. How do we do this? We can use b squared minus 4ac. So what does meeting mean? The roots must be real, or the roots can't be imaginary, because real roots mean that they meet. They don't have to be equal. Real and distinct, that's fine. So b squared minus 4ac, or minus k plus 3 whole square, minus 4 times 1. There's an imaginary 1 before x, and c is 2 plus 2k. So we end up with k squared plus 6k plus 9 minus 8 minus 8k. And the final answer is k squared minus 2k plus 1, which can be simplified after middle term breaking to write k minus 1 whole square. How did I do this exactly? Check this. This is k squared minus k plus 1. So we end up with k minus 1 minus 1 k minus 1, which is k minus 1 whole square. So what are the values of b squared minus 4ac? It is k is equal to 1, or since k is always positive, they will meet for all the values of k, because we want b squared minus 4ac, right? We want b squared minus 4ac to be greater than 0 for this to be valid. So the value for b squared minus 4ac is k minus 1 whole square is greater than 0. Now if you do solve this, what do we get? Basically, um, in the mark scheme, they said that since it is always greater than 0, hence it will meet for all values of k. But you could write it in different ways. Mainly here, what I did was, after finding out b square minus 4ac, I end up with k minus 1 whole square, where k is a constant, right? Now, regardless of what value we take, okay? For example, what if I take k is equal to 4? What do we get? 4 minus 1 whole square. That is 3 whole square, which is plus 9. On the other hand, what if I took k is equal to minus 4? We would get minus 4 minus 1 whole square, which is minus 5 whole square, which is also 25. So if you are whole squared, right, even if you end up being a negative value, the whole square value will be positive. So that is what we mean to say, that k minus 1 whole square is always positive. So b square minus 4ac will always be greater than or equal to 0. When can it be greater than or equal to 0? I shouldn't have written k here. It should have been, since b square minus 4ac is greater than or equal to 0 for all values of k. That's why they will meet all the time. So check this. What if the value of k is equal to 1, right? So 1 minus 1 whole square, which is 0. But 0 doesn't mean the roots are imaginary, right? It just means that the roots are real and equal. So if you are whole squared, remember, the value will always be positive. A function is defined as fx equals to x squared minus 2x plus 5 for all real values of x. A sequence of transformations is applied in the following order to give the graph of y is equal to gx. Sketch parallel to the x-axis, sorry, stretch parallel to the x-axis with scale factor half. So guys, let's draw the graph. What does x squared minus 2x plus 5 look like? Let's find it out. I'm using my calculator to find the critical values. 1 minus 2, 5. So when x is 0, y is equal to plus 5. 1, 2, 3, 4, 5. When x is 0, my bad, this 1, 2, 3, 4, 5. And what's the minimum point of our graph? F prime x equals to twice x minus 2. If we equate it with 0, that is twice x equals to 2, or x equals to 1. So if we input 1, 1 minus 2 plus 5 is equal to 4. So when x is equal to 1, it is equal to 4. So this is the minimum point. So the graph kind of looks like this actually. It does not cross the x-axis. So that's not really important over here. We don't need to draw the graph for this. But in general, I want to talk about something. Let's talk about the basic steps. Like a stretch parallel to the x-axis. What does that mean? This is actually a horizontal stretch where the stretch factor is half. So always remember, anything that you do on the x-axis, what will happen? If the stretch factor is half, you have to write 2 in the equation. It is inverted essentially. And you have to multiply this 2 with x only inside. For example, if it was a stretch parallel to the y-axis and we had a function fx, it would just be half fx, right? When the stretch factor, scale factor is half, if it was parallel to the y-axis. But now since it is parallel to the x-axis, it's going to be f times twice x inside, and you have to change the half to 2. It is inverted. Okay, so that's the first step. So all the x's that I have here, instead of multiplying, half, I'm going to multiply 2 within the brackets, within the multiplied with x, right? So it's 2x whole square minus 2 into 2x plus 5. Next, reflection in the y-axis. What does a reflection in the y-axis mean? Basically, this graph goes here. So it is a horizontal reflection, and sometimes you will get reflection in the x-axis. So for this to occur, you just need to give minus fx. For example, if this is fx, this one will be minus fx. All the values become negative. But here what happens, the values of y are positive, it's just that the values of x turn negative. So where do I need to put the minus? Inside, since this is a horizontal reflection. So I break down the, stretch. It turns into 4x squared minus 4x plus 5. Now I wanna reflect it on the y-axis, so I multiply the minus sign with the x over here, so we end up with 4 minus x whole square minus 4 into minus x plus 5. We end up with 4x squared plus 4x plus 5. Next, stretch parallel to the y-axis with scale factor 3. I just taught you it's just going to be 3 times fx, so 3 multiplied by the whole function itself. So 3 multiplied by the whole thing gives us an answer of 12x squared plus 12 plus 15, 12x plus 15. So that's how you do it. Okay, see if that's fine. Let's move on to the next part. A curve has equation y is equal to 1 by 60, 3x plus 1 whole square, and the point is moving on the curve. Find the x coordinate of the point on the curve at which the x and y coordinates are increasing at the same rate. Okay, so using this equation we can find out dy by dx. The power comes down, right? Since it was whole square before, the power will come down. The power comes down and the power decreases by 1. So 2 times 1 by 60 into 3x plus 1 to the power 1, and times 3 because we have to differentiate 3x plus 1 as well. After simplification we end up with 1 by 10 times 3x plus 1. Now they want us to find the x coordinate of the point where x and y coordinates are increasing at the same rate. What does that mean? Dx by dt and dy by dt, they are going to be increasing at the same rate. Okay, so hear me out now. We know that this can be written as dy by dx, right? Dy by dx is equal to dy by dt into dt by dx, right? Or it can be written as dy by dt into 1 divided by dx by dt, reciprocal, right? I can just bring it down there. Now here's the thing, dy by dt and dx by dt have the same value. For example, it's 3 times 1 by 3. So what can we do? We can just cut them out. That is exactly what I did in the right hand side over here. So dy by dx is actually equal to 1. Now 1 by 10 times 3x plus 1 is equal to 1. After solving this, we end up with x equals to 3. Okay, that's the gist. Moving on to question number 4. How many questions are there in total? We have 11 questions. It won't take that long. The circumference around the trunk of a large tree is measured to be 5 meters. After 1 year, the circumference is measured again and found to be 5.02. Given that the circumferences at yearly intervals form an arithmetic progression, find the circumference 20 years after the first measurement. So you guys should always write down the terms, then you're less likely to make errors. The first term is 5, then it's 5.02, then it's 5.04, 5.06, and so on. So we know that the formula for an arithmetic sequence is Tn is equal to a plus n minus 1d. So the common difference is actually 5.02 is equal to 5.00 plus d, because the second term 2 minus 1, which is 1d, that gives you the answer 0.02. That's the common difference. You could also do it mentally. Now they want you to find out the circumference 20 years after the first measurement. What does that mean? For example, we know that term 1 is 5, right? term 2 is 5.02, term 3 is 5.04, term 4 is 5.06. Now uh, the if you think about it carefully, they want you to find out the circumference 20 years after the first measurement. So 1 year after the first measurement, we get T2. 2 years after the first measurement, we get T3. 3 years after the first measurement, we get T4. So think about it. 20 years after the first measurement, we are going to get T21. So n will be one more than the number of years after, right? The first measurement. So we are tasked with finding T21, which is 5 plus 21 minus 1 times 0.02, which is 5.40. That is our answer. Next. Given instead that the circumference at yearly intervals form a geometric progression, find the circumference 20 years after the first measurement. Okay, so now we need to find out the common ratio, which is second term by first term, 5.02 by 5, which is 1.004. So now we just find out T21 again, 20 years after the first one. So T21 is equal to AR to the power n minus 1. That's the formula given in the data booklet. 5 times 1.004 to the power 21 minus 1, which gives us an answer of 5.42. Pretty straightforward. Let's go to the next one, question number 5. 7 questions left. So this is a question on circles. Points A and B lie on a circle with center minus 2, 5. The line AB has equation minus 2x plus 26. So let's see how to do this. Simply put, this is the diagram that I drew. And points A 7, 12 and B lie on a circle with center minus 2, 5. So minus 2, 5 is the center of the circle. And this point over here, 7, 12, is a point on the circle, point A. The line AB has equation minus 2x plus 26. Find the coordinates of B. So using these 2 points over here, A and the center, we can actually find out the radius of the circle, which is 5 minus 12 whole square plus minus 2 minus 7 whole square. We get root over 130. That's our first step, okay? Now, what do we do? We can actually find out the equation of the circle, right? Since we know that this is the center. So we know that the coordinates will be inverted. So what is the equation of the circle? X minus minus 2, which is x plus 2 whole square, plus y minus 5 whole square equals to 130. R square, right? So root over 130 square is 130. So we have the equation of the circle now. Now what's next? We are tasked with finding the coordinates of B. So we know that this equation, actually, if I draw the circle, it's something like this. We know that this equation, minus 2x plus 26, what does it look like? Plus 26 is somewhere over here, or somewhere over here. Basically, this is the equation of line AB. It's going to pass through A as well as B. Okay. And it's going to pass through A and B both. And it's going to cross the circle twice. Essentially, it's going to cross the circle twice. So what do we need to do to find out the other coordinate? Just equate this or input this into the equation of the circle. So y is equal to minus 2x plus 26. I just input that over here. And after solving it, this is the working, as you can see. We get this equation. solve it using the calculator, you can simplify it, right? What can we write? X squared minus 16x plus 63 is equal to 0. So after solving it, we get two solutions, 7 and 9. We have one of them already, which is A. So the other one is at 9. So what will be the accurate drawing of the circle? My x's are not according to scale, which is why I'm having a tough time drawing it. You need the coordinates of b, right? So to find that out, you can just input 9 into this equation over here. So minus 18 plus 26, which gives you a value of 8. So 9 comma 8. 9 8 is somewhere over here. So the circle looks something like this, basically. It's not a really good circle though, but yeah, you get the gist. This is point B. Moving on to question number 6. In the expansion x by a plus a by x squared to the power 7, it is given that the coefficient of x to the power 4 by x equals to 3. So yeah, you can use the nth term if you want to use the formula NCR, but I just expand the whole thing. So we actually end up with, the first term 7c0 x by a to the power 7 into a by x squared to the power 0. I didn't bother writing that. Plus 7c1 x by a to the power 6 a by x squared to the power 1. The power keeps on decreasing for one and increasing for the other one, right? Plus 7c2 x by a to the power 5 a by x squared whole square. So for the coefficient of x to the power 4, which one is it actually? Guys, this is x to the power 7. This is 6 minus 2, x to the power 4. This is 5 minus 4. This is 5 minus 4, x to the power 1. So we have them. I simplified them further. Now we just, after simplification, I just use this formula. So what's the coefficient here? It's 7 by a to the power 5 divided by 21 by a cube. It is equal to 3. So after you do solve this, I apply reciprocal 7 by a to the power 5 into a cube by 21. We end up with a square equals to 1 by 9. So a is actually equal to plus minus 1 by 3. Okay, since they said possible values of the constant a. Alright, moving on to question number 7. By first obtaining a quadratic equation cos theta, solve the equation. So tan theta sin theta equals to 1. So we can write tan theta is equal to sin theta by cos theta. So sin square theta is equal to cos theta. We know that sin square theta can be written as 1 minus cos square theta. So cos square theta plus cos theta minus 1 equals to 0. Now after you solve this, you end up with two equations. One being cos theta equals to minus 1 plus root 5 by 2. Also minus 1 minus root 5 by 2. You should at least show one step, using the general formula. We know that cos theta is equal to, minus b plus minus root over b squared minus 4ac by 2a. So we should show that it's, minus 1 plus minus root over 1 minus 4 into 1 into minus 1 by 2 into 1, which is minus 1 plus minus root over minus minus plus root over 5, right? Divided by 2. We should show this, and then I got these two answers. Thing is, if there's third form involved, please do show the work. So minus 1 plus root 5 by 2 and minus 1 minus root 5 by 2. Now, if you try to solve the right one, you'll get not math error in your calculator because it's maybe less than minus 1. So this is not applicable. This is excluded. And for the one on the left, we get two basic acute angles. If you solve this, it's minus 1 plus root 5 divided by 2 cos inverse answer. We get 51.8 plus 51.8. For cos alpha, the rule is, for cos theta, sorry, cos, the rule is alpha and minus alpha as the basic acute angles. For sine, it is alpha and 180 minus alpha. And for tan, it is alpha and 180 plus alpha. So in this method I don't use the quadrant method, which is wrong. It's not the correct way to do it. Trust me, you'll learn this in A2. It's better if you learn my method. I take the sign into consideration. If it was negative, I would take the sign into consideration, and I just go for, cos inverse the negative value or the positive value. So I get a positive value and I get its corresponding negative value as my basic acute angle. So these two are my basic acute angles. Now I want to check the domain to see where it lies. It's from 0 to 360 degree. So I know that I might have another answer, so I can add or subtract 360 degrees with all my values. There's no point adding 360 to this or subtracting 360 from this, so I'm just gonna add 360 with this value over here. So I get 308.2, and these are my only two answers. All angles to one decimal place, by the way, right? But all other answers to three significant figures if irrational. Is this fine? Let's go to the next one. Show that tan theta by sin theta minus sin theta by tan theta equals to tan theta sin theta. So we start with LCM. The LCM is sin theta tan theta, and up there we get tan squared theta minus sin squared theta. Tan squared theta can be written as sin squared theta by cos squared theta, where we can apply LCM again, and in the denominator I can also write tan theta as sin theta by cos theta. What's next? Up there I'm going to do LCM again, so that's cos squared theta in the denominator and sin squared theta minus sin squared theta into cos squared theta, and here we have sin squared theta divided by cos theta. Now I'm just going to multiply them, or reciprocal, right? So this by this into cos theta by sin squared theta. You can actually take sin squared theta common here because both of them have it. So we can get rid of the sin squared theta on the top and bottom. So ultimately I end up with 1 minus cos squared theta into cos theta by cos squared theta. Now what can 1 minus cos squared theta be written as? Sin squared theta, right? So what do we end up with from here onwards? It's basically sin squared theta into cos theta by cos squared theta. So we can get rid of this and this over here. We end up with sin theta by cos theta into sin theta, which is ultimately tan theta times sin theta. See if that makes sense. So this is your working, okay? There are other ways to do this. Any way that works is fine. So yeah, I'm solving math papers after a long time. If you do want more math content, please do let me know. I decided to do this because mainly I didn't used to solve math papers much because there were already too many channels. It was saturated because people can solve math, right? But chem and physics are a bit more unique. But now a lot of channels got taken down, as you may have seen. So yeah, I'm just taking hold of the opportunity. The main reason was because I guess Cambridge took action against some channels which did papers which weren't released yet. Officially, I mean. So yeah, I have to avoid doing that. Last four questions. Question number 8, 9, 10, and 11. So let's begin. For 8, we have to find the perimeter of the shaded region. This part. The diagram shows triangle ABC in which B is right angle. The diagram shows triangle ABC in which angle B is a right angle. The length of AB is 8 centimeters. Okay. And the length of BC is 4. The point D on AB is such that AD is equal to 5. The sector DAC is part of a circle with center D. Okay. So since D is the center of a circle, length DC is also 5. So we mean to find out this arc length and this length of this chord. So let's begin. We can find out the value of AC pretty easily because it is a right angle triangle after all. So like 8 square plus 4 square is equal to AC square. So AC is equal to root 80. 16 plus 64, root 80. On the other hand, I want to find out the arc length over here. Arc length AC. How? So using trigonometry, we can actually find out this angle over here, the blue one, which is angle BDC. Tan BDC equals to opposite by adjacent 4 by 3. So BDC is 0.927 radians. So what about angle ADC over here? It's going to be, 180 minus that, or pi minus that, which is 2.21. I obviously use my calculator answers, because if you do not maintain precision here, your answer won't match. So please use your calculator answers, carry them forward. Now AC is equal to the arc, S is equal to the arc length, so S equals to r theta. So 5 times this value of theta, 2.21, gives you 11.07 using my calculator answer. So what's the perimeter? I just add these two values up, root 80 plus 11.07, which gives us an answer of 20.023 significant figures. Okay. Next, area of the shaded region. So sector minus triangle. Sector area is half r square theta, and triangle area is half AB sin theta. So radius is 5, and theta accurately is 2.214297. Okay, minus half into 5 square into sine 2.214297, which gives us a final answer of 17.7 centimeters square. Pretty straightforward. Just ensure that you maintain precision throughout your answer. Okay. Moving on to question number 9. We just have 3 left. State the range of f. So first things first, let's draw the diagram. Okay. How? We know that fx equals to minus 3x squared plus 2. So I find out f minus 1. How much is it? Minus 1 whole square, which is 1, times minus 3, which is minus 3, plus 2 is minus 1. So at minus 1, my graph is also at minus 1. Next, for f minus 2, we get minus 2 whole square, which is 4. 4 into minus 3 is minus 12, plus 2, which is minus 10. At minus 2, it is minus 10. And if you keep on getting more negative values, it's just going to keep on going downwards to the left hand side as we keep on proceeding to the left. So what is my maximum value for this particular domain? It is minus 1 on the y-axis. So my range is going to be fx is less than or equal to minus 1, if that's fine with you guys. Next, let's find it's a one-to-one function, so we can find the inverse. Let fx be y, so y is equal to minus 3x squared plus 2. Make x the subject, we actually end up with plus minus root over 2 minus y by 3. But as you guys know, you can only take 1. So a simple trick is, if the domain is less, if the domain has a less than sign, just go for the negative one. That's a simple trick, but I'll show you how you can check. So for the other one, it would have been plus root over 2 minus x by 3. Just input a random value. Okay. For example, what if we input minus 2? Minus 2. Actually, let's use another value. Yeah, minus 2 is fine. 2 minus 2 is 4 by 3. So that's minus 4 by 3, which is a negative value. But if you do input it here, we are going to get 2 minus or plus 2 by 3, which is plus root over 4 by 3. So why is this wrong? We know that for an inverse and its main function, they're just a reflection on the x-axis firstly, right? So if I draw y is equal to x line, my bad. So if I draw the line, it's going to look something like this. At minus 1, it's going to be minus 1. And since that was minus 10 at minus 2, my inverse graph will be minus 2 at minus 10 on the x-axis, right? Something like this. So if you do draw the graph, it's gonna go like this. So hear me out. When x was minus 2, fx was minus 10, right? Sorry, I think I drew the graph wrong. My bad. At minus 10, it's minus 2. It's gonna be something like this. My bad. Here you go. Yeah, now it looks better. Now, you have to realize that the domain of the main graph is the range of the inverse graph. But we can just check using the graph. Check this. When I input minus 2 in my inverse function, when I put in f inverse minus 2, here I get a negative value, minus root over 4 by 3. How much is that? Root over 4 by 3, which is minus 1.15. And here I get plus 1.15. Now, clearly, according to my graph, when I put in minus 2, I'm supposed to get a negative value because it lies below the x-axis. So clearly, this one is wrong, okay? So that's how you check diagrammatically. But I just prefer doing it the easy way, you know? If I see a less than sign, I just put in minus. I'm a simple man. Moving on. The function g is defined by gx equals to minus x squared minus 1 for x is less than or equal to minus 1. Solve the equation fgx minus gfx plus 8 equals to 0, okay? So gx is minus x squared minus 1. So let's find out fgx first. What does that mean? I'm going to input g inside f. I'm going to input g inside f. So let's do that. So do you see this x here? I'm going to put g inside here. So fgx is minus 3, and inside the bracket we have minus x squared minus 1 whole square plus 2. So the minus sign doesn't really matter, since after whole square turns positive. We actually end up with minus 3 inside the bracket x to the power 4 plus 2x squared plus 1 plus 2. This is the end result after simplification. And for gfx, I'm going to put in fx inside this x of g. This is fx. I just put it inside this x, so that's minus, and inside the bracket I have minus 3x squared plus 2 whole square minus 1, so that's minus 9x to the power 4 minus 12x squared plus 4 minus 1. After simplification, this is the result. Now, we want to solve fgx minus gfx plus 8 equals to 0. Let's do it. So fgx, this part, minus gfx is equal to 0. This part is gfx. Three x to the power 4 minus 6x squared minus 1. Oh, and there is also a plus 8. My bad. I was wondering where it came from. Now, after simplification, we end up with 6x to the power 4 minus 18x squared plus 12 is equal to 0. And we can simplify it further to end up with this. Now, here we're going to let x squared be a, so we end up with this. A squared minus 3a plus 2 equals to 0. So let's solve that. X squared equals to 2 and x squared equals to 1. So here in the top, it's given that x can only take negative values. So if you do root over, you end up with x equals to plus minus root 2, and here x equals to plus minus 1. But we are only going to take the negative one, since x is defined for x is less than or equal to minus 1. So save that, it's fine. This was a pretty complicated paper, right? There are many places where you can lose marks, so just be careful. Personally, I find P1 harder than P3, honestly, because P3 is more systematic. P1 is just really random stuff. The Majun 2023 paper was apparently really hard as well. Moving on. Last two questions. Question 10, at the point 4 minus 1 on a curve, the gradient of the curve is minus 3 by 2, and dy by dx is x to the power minus half plus k. Show that k equals to minus 2. So what does gradient mean? Gradient is dy by dx. So I'm just going to input dy by dx as minus 3 by 2. So minus 3 by 2 is equal to, where x is equal to 4, 4 to the power minus half, that's given in the question, plus k. So after solving this, we end up with k equals to minus 2. Now find the equation of the curve. We need to integrate dy by dx, right? So y is equal to x to the power minus half plus 1, which is plus half, divided by half. And since dy by dx, after solving it, we end up with dy by dx equals to x to the power minus half plus, sorry, minus 2x. After integration, we end up with y equals to x to the power half by half minus 2x squared by 2 plus c. This is my integration, right? And to find out c, I use these 2 points, 4 minus 1. So we actually end up with minus 1 equals to 2 root 4 minus 2 4 is 8 plus c is plus 3. So this is our equation of the curve. Okay, pretty straightforward. Next, we are asked to find the coordinates of the stationary point. How do we do that? We need to equate dy by dx with 0. So we have the equation of dy by dx, which is x to the power minus half minus 2. If we equate that with 0, we end up with x to the power minus half equals to 2, or 1 by root x equals to 2. After cross multiplication, root x equals to half, and therefore x equals to 1 by 4. Now, we need to find out the y coordinate. How? We are going to input the value of the x coordinate inside this equation that we found out in part 2. So y is equal to 2 into 1 by 4 to the power half minus 2 into 1 by 4 plus 3. After simplification, we end up with y is equal to 3.5. So these are our coordinates: 1 by 4 and 7 by 2, but in the mark scheme they wrote 3 whole 1 by 2. 7 by 2 can be written as 3 whole 1 by 2. Recently, I've been seeing that they do not prefer improper fractions. Okay. Determine the nature of the stationary point. We know that to find out the nature, we need the second derivative, d square y by dx square. So let's differentiate it again. So the power will come down, minus half x to the power minus 3 by 2. Half minus 1 is minus 3 by 2. I input the value of x, 1 by 4. I get a value of minus 4. So since this is a negative value, it's actually a maximum point. Okay, that's our answer. Now, the last question of the day. The diagram shows the curve with equation x equals to y square plus 1. The points A, 5, 2 and B, 2, minus 1 lie on the curve. Find the equation of the line AB. Pretty straightforward. Just find out the gradient. Then just choose a random point. I chose A. Y minus 2 is equal to the gradient 1 multiplied by x minus 5. I used y minus y1 equals to m x minus x1. We get y is equal to x minus 3. Next, 9-mark question. Find the volume of revolution when the region between the curve and the line AB is rotated through 360 degrees about the y-axis. So when they say y-axis, the limits need to be taken from the y-axis. Okay. So what is the limit over here? It's 2. And what is the one over here? It is minus 1. So it's better to do it separately if it's volume and not area. Okay. So I'm going to find out the volume of revolution for this segment over here, the one below the curve, and then once again for the one below the line, and then I'm going to subtract them. Okay. So let's do it step by step. Or I did it together here. It's fine. You can do it any way you want. And make sure you do something else. When they say it is rotated about the y-axis, the first thing is the limits need to be taken from the y-axis. Also, you need to make x the subject because we are going to integrate with respect to y. So let's make x the subject. For the line, it is x equals to y plus 3. And for the curve, x is already the subject. So That's less trouble. And the formula for volume is, in general, integral. There's a pi here, and if it's for the x-axis, it's going to be y square and with respect to dx. But in this question, it is rotated about the y-axis, so volume is equal to pi integral x square times dy. We are applying this formula over here. So I input pi, and if I do x square, it's y plus 3 whole square, and dy, the limits are 2 minus 1 for both of them. That's the line. And for the curve, it's x equals to y square plus 1. So that whole square, and obviously you need to input the pi and the limits. So if you break this down, you end up with integral limits 2 minus 1 y square plus 6y plus 9, and for the curve it is y to the power 4 plus 2y square plus 1. Now let's integrate this. Y cubed by 3 plus 6y square by 2 plus 9y. On the other side, y to the power 5 by 5 plus 2y cubed by 3 plus y. Now input the limits. This is what you get. 8 by 3 plus 12 plus 18 minus, oh, I took the pi common, by the way, minus, inside the bracket we have so what is this exactly? This is for the first part, by the way. Okay, so 8 by, I input 2 here, 8 by 3 plus 12 plus 18 minus, then I input minus 1, minus 1 by 3 plus 3 minus 9. Please be wary of the minus sign in between. And for this one, what do I get? 2 to the power 5 is 32. 32 by 5 plus 16 by 3 plus 2 minus, and inside the bracket I do this again, minus 1 by 5 minus 2 by 3 minus 1. Now if you deal with the minus signs properly, after simplification you get 8 by 3 plus 30. I added this up, plus 1 by 3 minus 3 plus 9, and here it's 32 by 5 plus 16 by 3 plus 2 plus 1 by 5 plus 2 by 3 plus 1. So after simplification we end up with this, and this is our final answer. But I just told you they prefer improper, they don't prefer improper fractions, they prefer mixed fractions, so we are gonna go with this. So please be careful and convert them all the time at the end. Okay, so yeah, that's it for today. This paper was pretty hard, I'd say, and the working in some sums were complicated, and the final parts were a bit hard, but overall it's doable. So I'll be doing more papers often, math papers. I hope you like the content, and please do like the video. And special mention to my $15 patron, Pearl. He's the only one right now. You guys can join as well if you want. The link is in the description. You get access to video calls with me, my notes, as well as the solved question papers, so all of them. Alright, so please take that into account. It's patreon.com/CIE paper solved. I'm gonna link the playlist for P1 up here, math, and I'm gonna link the paper for February March 2022 paper 1-2 up here, and the video for um, S1 February March 2023 5-2 down here. Subscribe to the channel if you like the content. See you guys.